Well, here I am again. Let's go to another problem. We're going to skip over problem number 2 for now. In this one, it's going to turn out that the question is, why must it go back up again? But we're going to stick with the problems where the overriding question turns out to be, why must it come down? Okay, so for this one, we're given an equation, or well, the whole thing says, I figured out that the area of my garden is to be A of t, or the area, is equal to negative x squared plus 70x, where x is the width of the garden, and A is the area of the garden. So, let's do the same thing we did before. I want to sketch a graph. It is, again, going to be a parabola opening down. I think you all got that one right on the last video. To find the vertex, I use negative b over 2a. That will give me the x-coordinate of the vertex. A is equal to negative 1. B is equal to 70. So negative 70 over 2 times negative 1 gives me 35. So that is the x-coordinate of the vertex. If I plug 35 back in for both of the x's in the equation, I will end up getting 1,225. What does that point mean? Okay, well then now let's keep going. The a of x-intercept, which is the same as saying the y-intercept. Remember, y-intercept is always easy. You plug in 0 for x. If I plug in 0 for x, in this case I get 0 for y. To find the x-intercept, you set y equal to 0 and see what you get for x. I'll do that right here. 0 is equal to negative x squared plus 70x. I factor a negative x out of both of those terms, get x minus 35. I'm sorry, x minus 70. Okay, which means that the two x-intercepts are 0 and 70. Let's go ahead and draw the graph. I go to where x is 35. A of x is 1, 2, 2, 5. That's the vertex of the parabola. The x-coordinate, the y-intercept is 0. It should have been evident. I kind of could have saved myself a little bit of work by seeing that since the y-intercept is also one of the x-intercepts, the x-intercept is a distance of 35 from the x-coordinate of the vertex, then I know that the other x-intercept has to be exactly the same distance and will occur at 70. And there is the rest of the shape. All right, so let's interpret the vertex. Well, in order to do that, we want to remind ourselves of what the axes mean. The x-axis is the width of the garden. The y-axis is the area of the garden. I think do I tell you it's in feet anywhere? Okay, so looks like I left that out. So let's assume it's in feet. So the x-axis is the width of the garden in feet. The y-axis is the area of the garden in square feet. So according to this graph, when you make the garden 35 feet wide, you will have the maximum area of 1,225 feet. Well, does it make sense that if you make the garden even wider, let's follow the graph down. So this makes sense, okay? If the garden is 0 feet wide, the area will be 0 feet. As you make the garden wider and wider, the area increases. That probably makes sense to everybody. If you make the garden 35 feet wide, the area will be 1,225. Okay, why not? But then you make the garden wider, and the area decreases. It's going down. What's making it go down? Well, let's go on to the next problem, see if that is any more sense. It looks like a similar problem, maybe something more interesting or something that makes more sense will happen here. So a lot of things seem like they're exactly the same. It's a very similar equation. You can tell that it's going to be a parabola opening down. Negative b over 2a will be negative 140 over 2 times negative 2. So we still end up getting 35 as the x-coordinate of the vertex. Now if we plug 35 back into the equation, we get 2,450 for the y-coordinate of the vertex. The y-intercept, plug in 0 for x, get 0 for y. Let me start drawing the graph now. If the vertex is at 35, 2,450, I can put the point right there. I know that the y-intercept is 0, 0. That's also one of the x-intercepts. Now I'll save myself a little work by saying I know that the other x-intercept has to be at 70 because of symmetry. A parabola on either side of its axis of symmetry will look exactly the same. So we already know how to fill this in, 0, 0, and 70, 0. And you should be able to answer all of the questions, except they still don't make sense. Why? Makes sense that the area increases as the width increases, but why does the width why does the area start going down as the width keeps increasing? And how come we're getting 0 area when the width is 70 feet? Okay, something is missing. There's something, some of you may have figured it out. There's something in this problem that I'm not telling you. Let's see if we go on to problem 5, if this helps explain it. Well, this problem looks even more difficult. I'm not even giving you an equation. You have 240 feet of fencing. You want to fence in a garden next to your house, so you'll only need to put up fencing on 3 sides. Find the equation that tells you the area of the garden as a function of its width. All right, so I think I will draw a picture for this. So here is the house. Okay, because house isn't really important, but just because it's there, I know I'm not going to need any fencing. So now let me draw the fence in order to have a garden right up next to the house. I won't need a fence on the 3rd side. I just need the fencing on 3 sides. So I'm going to call the width x. Both of these will be x. For now, I think I'll call the length y. So we know that the amount of fencing we have, 240 feet, will have to be equal to what we use on x, the side of length x, the side of length x, and the side of length y. So 240 feet of fencing altogether will have to be sufficient for 2x plus y. Well, that doesn't tell me anything about the area. That's just the equation that's telling us about the amount of fencing that we're using. So let's talk about the area now. Okay, so what is the area of a rectangular garden? Well, it's going to be the length times the width. In this case, we're saying that the length is y and the width is x. From this information, though, it's going to be possible to rewrite this equation so there's no y's in it. I can solve it for y. Y is equal to 240 minus 2x. So if that's the case, then I can also write a of x as 240 minus 2x times x. That equation becomes negative 2x squared plus 240x. Now it looks just like or very similar to the two other problems we were solving. Think about this a minute. Do you now have an idea of why you reached some kind of a maximum area, and then when you increase the width even more, your area decreased? Well, let's continue with this problem. The vertex, negative b over 2a again, is equal to negative 140 over 2 times negative 2, which is equal to 35. I plug that 35 back into the equation. Oh no, I'm looking at the wrong problem now. Bummer. Okay, let's see. Let me erase this. Eraser went away. Okay. So now I'm looking at, this will have to be another video. Bye-bye.